Hello and welcome to the first session of BICA video panels, which is going to be today on the BICA channel challenge. I am happy that all you were able to join us. So first I would like to introduce myself. I have to be the host right now. My name is Alexei Samsonovich. Now we have Andrea Stocco, Antonio Chella, Brandon Rohrer, and the topic today is the discussion of BICA challenge. You all have the agenda in front of you. Now, if people want to join us as the audience, they are welcome to ask questions over the phone. I have this phone in the speaker mode. It should be working right now, so if you want to ask questions in the middle, that's okay. Now sorry, I did not receive preferences from anybody except Andrea, and I guess Andrea is going to start. So here is the list of 5 questions. Okay. And I would like to know which question are you going to start with?
Well, I will start with the question number 1 about the BICA challenge.
Okay.
Which is very appropriate. The question was whether the BICA challenge makes sense. And the idea of the BICA challenge is actually that the big breakthrough that we are expecting from artificial intelligence is going to come in the form of a cognitive architecture, in the sense of an architecture that's computational, but is inspired by the science of the mind.
Mm-hmm.
And well, my personal reason and my background is in neuroscience and cognitive science, and I've been working more and more in this computational attempt to try to merge the two. But I believe that actually the challenge is interesting because the more the system becomes complex, the more the way the system behaves is governed by high-level design, and the architecture is a way of putting things together. So while the breakthroughs at lower level are getting increasingly more interesting, complex, and more capable in terms of potentiality, putting them together in something that is organized relies on the architecture. And as far as we know, the one architecture that is proven to work in intelligence is the human mind, or if you want, the primate mind and the primate brain. And for this reason, I do believe that BICA challenge and this forum of putting together computer scientists, robotics, neuroscience, cognitive science is going to work in the future.
Great. Does anybody want to add something to this? Antonio?
Yes, I want to. Obviously, I agree with Andrea, and I want to add something about this topic. I think that obviously neuroscience is very important for BICA. Studying neuroscience is very important for BICA. However, I have to notice that sometimes the neuroscientists have a different interest from people from computer science, and it is very difficult to understand each other. For example, Andrea is a rare exception of this trend, but in general, I myself found very difficult to understand people from neuroscience. However, I have to say, also because people from neuroscience are different interests, because they are more interested of the illness of patients, for example, to find new cures for patients. And so I think, however, there are some interesting theories that came from neuroscience. For example, the information integration theory by Tononi is a theory from neuroscience, and it should be applied to BICA. In my opinion, it is difficult to understand each other. So I have one proposal, for example, for BICA. Why don't we think, for example, to organize some kind of tutorial, for example, for neuroscience, for computation, for computer science and the reverse, for example, neuroscience, for computer science for neuroscientists. In my opinion, one of the missions of BICA should be to facilitate, I can say, to make more easy to understand each other. This is my view.
Great idea. I agree.
I agree too.
Brandon.
Yeah, so just to follow up on what Antonio just said, it's been my observations too that computer scientists and neuroscientists tend to speak different languages, and often the difficulty in understanding each other is like, you know, one of us was speaking English and one of us was speaking Italian, and
yeah.
And I agree that tutorials is a good step in the right direction, but my guess is that to really be able to understand each other, members of the community will have to individually invest quite a bit of effort. Based on my experience, to really learn the language of a field, you have to be immersed in it, you know, for a good couple of years. And Andrea, I'm suspecting that your exposure to computer science that allows you to communicate neuroscience to computer scientists has probably been more than a few tutorials. It's probably been extensive. Is that accurate?
That is accurate indeed. Actually, my undergraduate studies were in computer science and artificial intelligence, and then I switched to psychology and neuroscience.
Okay.
But the interest is out there. There are problems with language. There are problems with having different goals and different priorities. Computer scientists tend to focus on the big picture as long as it's functionally working. Neuroscientists tend to focus on the small picture, and they want something to be perfect, a perfect description of the system. And they tend to be overlooking the big picture and the functional similarities between alternative systems. But there is an increasing willingness to, you know, overcome certain things. Here at the University of Washington, for instance, a big push for integration is being with the research that lots of people in neuroscience and computer science and engineering have been doing on brain prosthetics.
Yeah.
Which is a cool topic, but it's also a topic that forces different people to work together at the right level of communication.
Yeah, no, that's interesting. It's very interesting. I had a thought, but I forgot what it was. I just lost it. Anyways, I'll have to come back to it later.
So should we have a tutorial on neuroscience at our BICA conference?
That could be interesting.
We also need time for it.
It never helps even to have a overview, because people who don't work in neuroscience, it's really easy to, you know, take one or two bits of information and run with it and forget the rest. So it's always.
Yes, it's true.
Yes.
But anyway, it should be an idea that we have to think about.
So how about the first question? Do you think the second question, do you think that a big breakthrough is possible in artificial intelligence in the near future? Just today I received a response from one of the audience members who said that no, I believe that we will see a steady incremental progress in artificial intelligence, contrary to what we hear from Kurzweil, from Werner Winch, and many other people. So what is your opinion?
Well, I'm not, if I may start, I'm not a fan of this kind of ideas of singularity. I do agree that there should be an incremental progress. It is very difficult to forecast the future. In my opinion, what is missing in BICA, in the BICA community, is we need to have more effort toward applications. So I saw that there are a lot of studies in new architecture, in explaining the architecture, new cognitive architecture, while I would like to see more application, also new kind of application, for example, cognitive architecture for cellular phones, or cognitive architecture for social network, for music, for cars, and so on. For example, I have in these weeks, I had a sort of experience of collaboration with our local civil service, and I noticed that they do need a lot of cognitive architecture to organize, to manage their works. So what I would like to see in BICA is not a real breakthrough, but many incremental progress towards new kind of application. And also in this case, I do feel that the BICA society should facilitate, should give ideas, should give some sort of, I can say, I don't know, some way to facilitate this way to apply our architecture in real world.
Excuse me, and how is this new kind going to be different from what we have today?
I don't know. For example, I would like to see bike application for cellular phones. Or for example, as in Facebook, in social networks. I don't know. I would like to see new kind of application. I think that this would help also to for us to develop new kind of architectures. So this is my.
Okay, thank you, Brandon. What do you think?
So I think that it's fun to make predictions, but I don't think that we have a very strong basis for having a lot of confidence in predictions. So I see it mostly as has high entertainment value, but low scientific value. And personally, if I had to make a guess, looking at past revolutions such as how the invention of the assembly line or the advent of the internet has changed society, or the automobile. Viewed from a historical perspective, those changes were explosive and completely transformed society. But from the point of view, for instance, all of us were present as the internet was developed and became ubiquitous. On a day-to-day basis, it didn't necessarily feel like the world was being rebuilt around us. Mm-hmm. And I'm guessing that any changes due to cognitive architectures will be similar, that it'll be subtle, and it'll only be through the hindsight of history that we'll see it as being big and dramatic. But one thing, though, I really agree with you, Antonio, about it will be fun to see things applied. And so Andrea, I'm probably revealing my bias toward the computer science version of seeing things. A big picture, a widget that does something is fascinating to me. Even if the details don't really mimic what's going on in the brain, it's fun to tell stories about what happens in the brain, to have models of varying resolutions. Not just fun, it's scientifically very valuable. But my personal bias is that we don't know enough about how the brain works on a fine scale to deduce what's going on functionally. We know enough to make some very educated guesses, and there's a lot of information there that's intriguing, but you can see by the wide variety of theories about something as well defined as what does the cortex do. There's no consensus on that.
And do we believe we need to know before we can build something intelligent? As intelligent? Do you believe that we need to know all these details before we can build something as intelligent as a human?
Personally, and this is not a scientific opinion, but a bias or a gut sense, I think that the human brain is a really valuable source of insights about how this can be done in one way, and neuroscience and psychology, cognitive psychology, is a really rich source of insights, but that we don't necessarily have to know every detail. We may not need to know every detail before we're able to build a very high-performing artifact.
Okay, thank you. Let me now ask Andrea, what do you think about this last question? Why is this the case that computers are still clueless, even though it seems like we have computational powers? And there are models that cover virtually all aspects of human cognition and learning.